Welcome back. Today we're going to talk about processes. And I've got a question for Daryl. Do you think creativity can be described as a process or not?
Well, I absolutely do. And it's what you and I do all the time with our students. We go through a problem-solving method. You know, it's one of the myths, and you talk about these myths.
Yes.
One of these myths that you have to throw away all the structure in order to be creative.
Right.
And it's also a myth that some of us have that ability and some don't. But people who are creative, that I see are creative, usually have a process that they go through. In our case, we work through something like the scientific method. We both learned it in 3rd grade, but we didn't really understand it.
That's right.
And the problem-solving method has what? You define a clear problem, you look at the background, you form an educated guess about what's going to happen, you run your experiments or do the work, and then you report on the results and conclude. And those steps form the same basis for how my students do their research at the PhD level. And it's how we can solve problems really at any level. Let me give you an example.
Okay.
In this MOOC, we have had to solve a number of problems. And one of them, as you know, that we struggled with early on was how are we going to get this course in place, form a syllabus, a structure of course of lessons, so that we could finish it in time to start this course.
That's right.
And we went through a number of items that we were not successful at. And then we brought an expert, Kate Miffett, on board.
That's right.
Who said, you know, I think the project might serve as a nice spine for this. And then we started putting the pieces off of it. So we defined the problem by making it smaller, by breaking it down. Instead of just saying, how are we going to get this course done? We said, how are we going to fit the pieces off of this spine of the project in the course? So we narrowed the problem and made it clear.
That's right.
Asking good questions is the hardest part that I see, even for my students in chemical engineering, PhD students. It's so hard to ask a good question. The next thing we did is look at the background. What were some of the other MOOCs doing? We wanted to find what were the best practices. It's a relatively new area, but we wanted to find the best practices and pull them into what we were doing so that we could move forward. At that point, we were down to the part where we're doing a lot of the work. We're writing the concise scripts. We're making the videos so that they present the information and the content that we want, both the knowledge content and the emotional content. And so we went down through this process as we went, and that's how we created this course.
And do you think that it's an effective process?
Well, I think it is an effective process, and the scientific method can be applied across many spectra. And it's not the only problem-solving method. I mean, you're probably accustomed to a number of other methods yourself in your own work.
There are probably dozens of models for the problem-solving process. 2 of my other favorites, including, in addition to scientific method, there's one called the creative problem-solving process that was invented by the folks at the Creative Education Foundation. Interestingly, by one of the people who invented brainstorming, a fellow named Alex Osborne. And it has very similar stages to the ones that you're talking about. There's also something called design thinking, which is also well known in the design world and in the engineering world. Design thinking has a lot to do with Jack's intelligent fast failure. There's a prototyping stage in that testing stage. It's used at places like SAP, the software company, and IDEO, the design company. So there are many examples of those problem-solving processes with very similar stages.
Yeah, and with these stages, sometimes you have to iterate back. So after you go through and you run some experiments, oftentimes you need to go back. You have a prototype, you need to feed it back.
That's right.
Well, now I think it's a student's turn. Start with a problem or a project in your corner of the world. And in that, define 1 or 2 good questions. Break it down into 1 or 2 good questions. And then use one of the problem-solving techniques we discussed. You can use the problem-solving technique that I described at the beginning of this lesson, or you could use one of the problem-solving techniques that Catherine described earlier. That's it for today. Thank you for joining us.